Assalamu alaikum wa rahmatullahi wa barakatuh. We'll continue with chapter 7, structuring system process requirement. And as we see in lecture 1 and lecture 2, we work on the process modeling, DFD, start from a context diagram, and then level 0 of DFD, and then we go all the way until we get primitive DFD. But as you see, logic modeling, it is different. Logic modeling involves representing internal structure and functionality of processes. Those processes are the one we've seen in the DFD. Logic modeling can also be used to show when processes and a DFD occurs. And even the flow diagrams are very good for identifying these processes. They do not show the logic inside those or each process. So we are going to cover logic modeling, in this lecture. Again, we'll see this diagram, which shows the system development life cycle and where we are at now. We are now in the analysis phase. We still with the requirement structuring, as we said earlier. We cover already the process modeling, and now we are going to do the logic modeling. And then after that, in the analysis phase, still one activity, which it is the data conceptual modeling, the ERD. By that time, we finish the analysis phase, and then we go to the design, and then after that, implementation, and so forth. Well, with the logic modeling, there are many outcomes and deliverables. First of all, like structure English, representation process logic, decision table representation, decision tree representation, and state transition diagram, sequence diagram, activity diagram. Those state transition diagram, sequence diagram, activity diagram, we cover them somewhere else in software engineering and other courses. But in this course, we're going to cover structure English, decision table, and decision tree. Well, with structure English, it is a modified form of English language used to specify the logic of information system processes. No single standard, no specific standard for this one. Typically relies on action, verb, and noun phrases, and contain no adjectives or no specific standard. Structure English, it is the pseudocode, we call it. The pseudocode, which it is abbreviated thing, a small specification, abstract specification, how to write, the program or whatever, uses a subset of English, action, verb, noun, phrase, no adjectives or no specific standard, as we said. Well, if we look at this example, for house burger inventory control system, we'll see, the level 0 of, that subsystem. We see 4 processes: 1.0 update inventory, 2.0 update inventory used, 3.0 generate orders, and 4.0 generate payments. And plus there is an inventory file there, and there are source and sink, which it is the supplier, and there is a source, which it is the stock on hand. So in the next slide, we're gonna go through these four processes, and we try how really to write structure English for them. So if we look at the first process, 1.0, which it is update inventory added, do until, we just say, it's like a loop, do until end of file. First of all, read, then find, then add. It is an abstract thing, specification in a language. Read next inventory item, then find matching inventory record, and then what really you have to do with that record, add, subtract, whatever we say it, until end of file. So this is really the end of it for this process. So here in this case we leave a room for the programmer to do how he gonna read it, So we don't tell him, in detail, read ABC from table 1, 2, 3, where the key of whatever. So, well, let's give him a room to try to use his technique, his experience, his skills, in writing, the read or the write, or then define the same thing and add. Well, we do the same thing for the second one, the process 2.0 and the process 3.0 and the process 4.0. Now let's see how, the decision table, modeling logic with a decision table. Decision table, it's really a concise visual representation for specifying which action to perform depending on a given condition. What do you mean by that? The condition, like if A, then if B, then if C, do X. Else, if A and B but not C, do Y. Else, if not A, not B, not C, do X, Y, Z, etc. So it's like really, it is like an algorithm whose output is a set of action. So decision table is a matrix representation of the logic for a decision which specify the possible condition for the decision and the resulting action. Of course, when we're gonna use it, we use it for complicated decision logic. Complicated when we have a nested if, like as I said now, if, then there is an action. Otherwise, you have to do other action. If it is this one true, then you do something. If it is true, false, you do something else. وهكذا. Let's see this example for decision table for payroll system example. The example here for a company, it has two types of employees. One of them salary and the other one's hourly. This means salary, they pay their salary and month, every month, no matter how many hours he works. 40, less than 40, or greater than 40, they pay the salary. But for the hourly, they pay him in the hour. So if it is less than 40, what really they are doing, they pay the number of hours. And then they calculate the absence. Then they put the absence, like if they work 38 hours, then they pay him for 38 hours. And they said, well, they are absent for 2 hours. If they work greater than 40 hours, they pay him 40 hours for regular salary, and for the overtime for these, the one which is exceed the 40 hours. So if you see here what really we have, the decision table, it has very important 3 symbols. The symbol on the left side, there are 2 of them, condition stops and action stops. And then the one on the top, rules. The rules, then we have rule 1, 2, 3, 4, 5, 6. If we see the condition stops, the condition is like if employee type is equal S, then if hour worked is less than 40, then what's then? In this case, the first rule, if the type is S, salary, and the hour worked less than 40, what really the action? The action, they pay base salary. So they pay him their salary. If we notice, if we look at rule 3, again, if it is salary and 40 hours, again, the only thing they do, they pay their salary. And rule 5, again, for the same thing. If it's salary and greater than 40, they pay him the base salary. But for the hourly, it is different. If it is hourly, which it is in H, the type, and the hours worked less than 40, they calculate hourly wage for those hours, and they produce absent report. But if it's hourly and 40, they pay him just, 40 for 40 hours. But if it is greater than 40, they pay him hourly wage for the 40, and then they calculate the overtime. Let's look at really rules 1, 3, and 5 and see how we can really simplify this table. If we look at the symbols in that table, and it's very, very important. So if you get an exam, a question to conduct a decision table, those are the important part which they should appear, in your table. The condition stop, the action stop, and the rules. Condition stop, here the part of decision table that lists the condition relevant to the decision, which it is if hourly, if salary, and less than 40, whatever those are. Action stop, the part of decision table that lists the action that result for a given set of conditions. And the rules, it's the third symbol or the third component of the table, the important one, that which it is a part of decision table that specify which action are to be followed for a given set of conditions. Like, if it is salary and less than 40, this is a rule. If it is salary and greater than 40, it is another rule. If it is salary and equal 40, it is a third rule. So in the rules, always it comes, in the number of the rules are even in the regular table, in the regular decision table. That's before we simplify it. Why? Because usually we have always the condition, if A, then either A or not A. Either A greater than A or less than A, or A. This means there are three. But the three is that one. If you have another two, if B after that, like you say, if A, then if B, if A greater than 10, then if B, if A less than 10, then B, if A equal 10, then B, which it is you multiply 3 by 2 equal 6. 2 by 2 by 2 equal 8. 2 by 3 by 2 equal 12. So usually the rules are an even numbers in the decision table before simplification. We have here, see, the indifferent condition. The indifferent condition, which is the condition which it doesn't make any difference. It's like the one we see in the example form. We said it doesn't make any difference if the hour is 40, less than 40, or greater than 40 for the salary employee. Like, if salary and less than 40 or greater than 40 or equal 40, they pay him the regular, their price, their salary. So here, the condition here, it is really indifferent. It doesn't make any difference. That's what really it means. In the decision table, a condition whose value does not affect which action are taken for two or more rules. And those are the one really we need to specify, to simplify them. For the indifferent condition, all these three, we can simplify them in one. In this case, we could say if the type is salary, then pay him their wage, regular wage or regular salary, whatever. So we don't have to put another F for the greater, less, or equal. So how really we gonna construct that table? How we gonna really create a decision table? First of all, we find the condition. Name the condition and the value that each condition can assume. Name all possible action that can occur. List all possible rules. Define the action for each rule. And then after that, we simplify the table by getting rid of the indifferent conditions. If we look at this table, this decision table, it is for the same as the one before. Used to be 6 rules, now there are 4 rules. The first rule, it is if the employee type salary and hour worked, I don't care. So we put hyphen there or dash. We don't care if it's less than 40 or greater than 40 or 40, because in all cases we pay the base salary. So this is a simplified table. But if it is hourly, so the less than 40, greater than 40 or 40, it really make a difference. So we leave them there. So really, we abstract, we simplify the table to make it just here 4 rules instead of 6 rules. And this is really make it easy and the developer and the programmer to translate this to a logic. If you look at this example for decision table, here it is kind of complicated. It has really 12 rules. Why? Because it depends on the type of item. Type of item is a P, perishable, or non-perishable, P or N. The time of week, is it weekday or weekend? 2 times 2, 4. And then the season, academic year, or summer, or holiday. It's another 3 type there. 2 times 2 times 3 equal 12 rules. So the condition stop, it is the type of item, important, the time of week, and the season of year. The activity here is, for inventory. Like reordering, the inventory for the Jose Burger inventory, the one really reside in like a university or whatever, because it depends here on the season. Is it academic or summer or holiday? And it is really weekend or weekdays, and it make a difference, how much really they order. And if we look at just 1 or 2 rules, if you see the first rule, if it is perishable item, and if it is a weekday, and if it is the season of the year is academic season, they order the standing daily order. Standing daily order, that's between the restaurant and the supplier. They tell them, send us every day 200 pieces of that, 300 pieces of that, 150 pieces of that, so the standard one. But if it is not perishable item, and it is the type of week, it is again weekday, and the season academic, the minimum order quantity. They just send them the minimum order. If you see that one, the minimum order, it is the same. It looks like for all activities of, minimum order quantity, it is for 2 and 4 and 6 and 8 and 10 and 12. So probably this one we could really simplify it, because it doesn't matter as long as it is, it is a DA, and we'll see how really we're gonna simplify this later on in that example. As I said in the previous slide, look at rule 7 here. Rule 7 here, if it is non-perishable item, always order the minimum order quantity. So the action is minimum order quantity there. So in this case, we just put N, and then for the time of week, it doesn't matter if it is, weekdays or weekend, and any season, if it's holiday or summer or academic year, it doesn't matter. For non-perishable item, just order the minimum order quantity. And that's why we have 5 rules. We simplify in 1 rule here. So what really we still have just 7 rules. It's like, the first rule, it's the same still. If it is perishable and weekday and season, you pay standard, you order standard daily order. If it is perishable and weekend, and you standing weekend order, there is another standing weekend order, because the weekend it is the order, or it's going to be less than the weekdays, because there are a few people work on the weekend, so that's why there is a standing weekends order, and so on. Well, with this slide, an example here, or we're going to talk about the modeling logic with decision tree. Decision tree is really a flowchart-like structure. in which each internal node represents a test and an attribute. It is actually, it's like a tree, but it's binary tree, either true or false. Then from the for true or false, another condition. It's going to be true or false. Then one of the false could be two condition, true or false. So we deal here with it as a binary tree. Each branch of that, attribute of that tree represent the outcome of the test, and each leaf node represent a class or a process. It is a graphical representation of a decision situation. Decision situation point nodes are connected together by arcs and terminate in oval, which it is process. There are two main components: decision point represented by nodes and action represented by oval. And it's usually read from left to right. We don't go, a tree, it's like from the root is on the top and then we go, no, the root, it is really on the left and then we go, to the right. Each node corresponds to a number choice and a legend. In the node, we don't put a condition, we put the number of that condition. But that condition, it is really be down there in a legend. And as we're gonna see in that in the example in the next slide. All possible actions are listed on the far right. If we look at the example of decision tree, we could really find the logic of the simplified table in the decision table in the example before. We use it here in the decision tree example. If you look at this example, you find the node. In the node, it has a number. So we have to have really in the node a number. We don't put really the condition there. We don't write in the node like salary. Look at the legend down there. It is the legend like مفتاح الخارطة, as we say, بالأطلس أو غيرها. If you look at one, is it salary? Yes. Go pay the base salary. If it is no, then you have another condition in the node, which it is number 2. Our works less than 40. Yes, we pay hourly wage and we write the absence report. No, then comes 3 hour work equal 40. Yes, pay the hourly. No, which it is mean that the hour work greater than 40, so they pay the hourly and then they calculate the overtime wage for him. Well, in the previous slide, that's it, for the logic modeling. We'll go here for an example for electronic commerce application, process modeling using data flow diagram. It's a quick example, how really you're going to handle this. First of all, process modeling for Pine Valley Furniture Web Store completed JAD session. So you go to the JAD session, you identify, you began translating the web store system into data flow diagrams, relation between, the processes. You identify actually the processes, identify 6 high-level process. This is really level 0, 1. Find the relation between these process, data stores, and sources and sync, and find the data flow, which it is really, this is the relation between them. So really number 2 and 3 here, find the relation between them and find the data flows, which it is really the relation between them, which process called the other one, what parameter you send, whatever, and all are represented in the data flow. If we look at the system structure of the web store, what really it has, if you look at the web store system, it has the main page, product line, catalog, desk, chair, whatever, shopping cart, checkout, account profile, order, then company information, feedback, contact information. What are the processes? It comes from all this system. Actually, browse the catalog, select item for purchase, then in the shopping cart, display shopping cart, you check out process order, then add modify account file, then order status. What's the request for the status, what's really the order status, where is it, whatever information display, minor or no process is it. So we identify all these things, and then we are ready to construct the level 0 of this project. The project, the name of it, of course, it is in the context diagram, but in the next slide we'll show level 0 of it, which it is represent the 6 processes we've seen in this slide. And as we said, we have to know and understand fully the relation between these, the flow of the system, how really what's the relation between this process and that process, and then we could add to it the data store, the databases, which it is part of the system. If you look at these 6 processes and the data flows, it goes from one to the other one, and the table, the data stores, it is really complicated one, you see. But actually, in the meantime, it is so easy. It's so easy if you understand fully the business. So when we talk about the data flow from the context diagram to level 0, level 1, whatever, I think you need to understand the system thoroughly in order to construct these kind of things. So if we, like in the exam, if you just bring a small question, like 10 pages or 10 lines or whatever, I think it will take you probably a couple hours to construct it. So in this case, in the exam, if I want to bring, a question to construct a data flow diagram, I think it's going to be trivial, so trivial, 2 to 3 lines, highlighted. The process are highlighted. It's easy for you to build the context diagram, which is the context diagram. It's easy, which is the name of the system, and from the question you could find out, who are the stakeholder, the external entity of the context diagram, and then after that, it's easy. You could find, how you're gonna compose, decompose that system, how you're gonna explode that system to its functionality. You'll find them later on in numbered, process 1, process 2, process 3, and you take that one and you make level 0. And if you want to go even further in that question, if I want to put, another layer of it to go to level 1, then I explain to you, like in process 2, we do A, B, C, then the process 2, you'll see it in level 0. But A, B, C, you'll find in the explosion of process 2, the one in level 0, and you could go and construct level 1. If you look at this one, those are 6 processes, but you have to understand all these data flow. How you going to understand them? By understanding the business and the business rules of that project. That's it for this lecture, and that's it for the chapter. Next chapter we'll go to the data conceptual modeling, ERD. By now we finished 2 parts of the analysis phase, and when we go to next chapter, the ERD, when we finish that ERD, then 1 week after that, the project phase 2 will be due. Thanks.